Another Draft Science video presentation. This one, we'll just keep it simple. We'll just do the paradox, one of them, and see if anybody can explain in comments, refer to any explanation that's reasonable, that makes it all okay. Makes what just doesn't make any sense at all, just proves the case that there's something very wrong with the conventional physics notion of the reality. So let's get as much of this as impossible. Well, that's close enough. Alright, so we have these competing formulas, and they are competing formulas. It was all created in an atmosphere of competition, clearly, and they get very different answers regarding how energy moves through objects in the universe. And the simple example is you take two carts or trains or whatever. One of them is stationary, one of them is moving. It's moving at 10 units of velocity and it has 5 units of mass, whatever that might be. You're going to connect it with another one that has 5 units of mass to start with, all right? And the velocity will be 5. Now that's the facts. If you transfer the energy very well, that is, you just connect the carts, that's the result you'll end up with, is that now you'll have 10 worth of carts when you connect them, obviously. 5 plus 5 will equal 10, so you can figure out that I've changed the 10 number. And it basically is an inversion, and the E equals mv equation, obviously it doesn't matter whether it's Vm or mv or, it's the same numbers, it's the same numbers. Obviously in this equation things go all kinds of crazy in terms of the lopsidedness. So they say the cart originally had 500 joules of energy, let's say, and after the complete transfer of every bit of whatever momentum is completely transferred, we only have 250 joules of energy. Now the situation is that I can take this cart, okay, that has this momentum, that has the same momentum as this. We could argue the momentum was 300 and it's 300 here. I'm just using numbers. It's 100 obviously if you do this math out. I think it comes out to 100. This would be 5 squared is 25 times 10, it's 125. So whatever. So we get a number, and the number we can convert it into joules or pounds or anything we want to, really. It's a real number. It's real mass times real velocity, and that's going to get you a real quantity number. It's an amount of something. And like I said, I can convert it just into pounds. Anyway, so the trick is that we can take this cart that has this momentum, and we can drive it right into another spring, another mechanism to store the energy, lock the spring at the deepest compression, and then just replace it with this cart, the single cart again, the 5 mass unit cart. And when we do that, we put the 5 mass unit cart here, all right, it will shoot it at exactly this 10 velocity. That's if, we're rather perfect in how all this happens. So we reduce the amount of frictions and heat losses and other environmental losses. And we'll end up with our 500 joules again. So obviously, it couldn't have lost this energy. This number is wrong, or this number is wrong. I'm arguing, obviously, they're both wrong, because we know the momentum is exactly the same. So the simple point is you can't completely transfer the momentum. That is, you've accounted for all of it. None of it seeping through the wheels, or if any of it seeps out, this number has to go down. This number can't stay 5 if you made sounds or squished bananas or did any other activity with your energy. If you didn't transfer your energy, this number can't be 5. And again, the simple argument is that how could this formula possibly be right when it gets these erroneous, crazy, silly numbers? And the energy disappears and yet it reappears, it pops into nothing, it goes nowhere, then it comes back. I mean, it makes zero sense. This can't be the right answer. And I would argue that in no circumstances is it ever giving the right answer. And if you really follow the energy, follow the heat, follow the noise, follow the sound, follow all the movement, you'll figure out that, yes, it's not getting the right answer. I mean, it's really understanding that things have to move, you know, and they can move as a big object, or the little bits inside of them can move, right? They can start becoming a different size object. And then the atoms themselves can be transformed, like, you know, cooking bacon or something. You can start changing the atoms and causing movement inside of them. All of that movement counts. Every form of the movement is what the momentum equals. So I guess that would be enough for right now. So keep it simple. So the simple paradox is you can't pour all the paint from one bucket into the other bucket and then say, I spilled a bunch of paint. Look, I lost half the paint to the environment somewhere. It spilled somewhere. Well, this number can't be 5 if you spilled any. And if I lower this number, if I make it 4 or 3, then this number goes down even further. And then you have to explain where you still lost all of this stuff. So it doesn't work. It's a proof that this theorem fails to describe the very simplest transfers. It fails. Catastrophically fails to be accurate. And that needs explanation. You need justification. The fact is the formula is doubtable because its history is flawed. So it's like the Eddington experiment never being redone. There's good reason to question. Not no reason. Good reason to be doubtful. And this provides even more evidence, just glaringly saying, maybe you chose the wrong team. Maybe your doubt of momentum had no real good reason except people didn't like Newton and Descartes. And maybe you should figure, I'm not going to stay with those guys. Maybe I'm going to say that maybe Newton did enough experiments to justify having an opinion you can trust. You know, and you don't have to trust it because you can see it works. And it'll always work. And they'll never show me an explanation of why this makes any sense, this crazy numbers. And they won't show me how momentum's wrong. That momentum was giving the wrong answer. See, momentum says, yes, you conserve the energy here, you transferred it, and you transfer it here. All the same number. 125, 125, 125, 125. Because I'm making whole objects move very efficiently. Now, true, we can't do perfect experiments, and we're always going to lose a little bit of the energy. But we'll change the number, 4.8, and then we'll change the number down here to 4.6. Okay? But we know that 4.6 is a lot different than 500 versus 250. All right. Yeah, I can't state it any plainer. So you're so confident your physics is right, even in spite of that evidence, in spite of the poor history of the theory, in spite of the fact that it's archaic, it's an old religion, so to speak. There's good reason to doubt. Yet you're going to be persistent and say, I'm crazy or stupid or idiotic for seeing there being a huge problem in the function of that equation. Like I said, all I can do is reason. If you can't do it in return, then the process just isn't going to go anywhere.